what we're going to do here is I'm going to put a fault in the engine ECM power. And I'm going to go to the fuse in the battery box, and I'm going to install a rheostat. And this rheostat goes from 0 to about 250 ohms. And what I'm going to do is I'm going to run the ECM through this switch, and then I'm going to flip the switch, which is going to run the ECM through the rheostat. I'm going to start at 0 ohms, and the engine should continue running fine. And then I'm going to very slowly increase resistance, which, if everybody remembers their Ohm's law, should make current go down. Well, it also causes a drop in voltage, so there's going to be a voltage drop across this resistor. Well, I'm also going to have a voltmeter hooked up, so we'll be able to watch me increase resistance. You'll be able to watch the voltage over the rheostat. We subtract that from 14, and that'll give us the voltage of the ECM. When the engine first begins to misbehave, we're going to figure out how much resistance that is. I want you guys to be able to see how little it takes to make this happen. I've got the meter set on max, so it's recording the maximum numbers. So you kind of got to watch carefully. Okay, the meter is showing 3.63 volts. I recorded it on the max setting, so engine shut down, and that's where the voltage drop. Occurred. And if I unplug this and then just turn the meter on ohms, because it's all hooked together, then I get 4.9 ohms. Notice I'm getting full system voltage. Well, that means I don't have an open or short, okay? And manufacturers don't teach us that either. They want us to jump through all these hoops with jumper wires and whatever. But the reality is, if you see system voltage, you don't have an open or short, okay? You rule those two out and you're done. But then the third step is to simply push the button, and when you do, the voltage drops down, in this case to 9.67. And the 9.67 volts means that there's a problem in the circuit, period. And because I have both leads in the connector, that means I'm testing 100% of the system, of the circuit, with one test. What's the next step? Well, all I know is that I've got corrosion in the circuit somewhere, but I don't know where. So what am I going to do? Well, what I'm going to do is move the black lead to a good machine ground, emphasis on good, and I'm going to push the button again. And when I push the button again, the problem comes back. Okay? That means the problem's in the positive. So I now know I have a fault caused by high resistance in the positive wire, and I'm done diagnosing. Now all I have to do is go find it. So let me zoom out and show you the entire process in real time. Meter's on volts. Remove the ECM power plug, plug it into the 2 pins, full system voltage, no opens or shorts, load the circuit, drops to 9.67, move the black lead to ground, repeat the test, drops to 9.67, I have a corroded positive wire. Throw the ghost and zero voltage in, and man, you got a heck of a diagnostic method. 3 companies have adopted the tool: Caterpillar, Volvo, and UPS. A lot of other companies use it, but those 3 companies have adopted it. They have part numbers for it, so that's credibility. But on 5 ohms, this dropped almost 3 volts. That's a distinct difference that could mean the difference between being out there for 10 minutes and being out there for 10 hours. You decide which one of those you'd prefer to do.